So next talk is our interview with Juan Benet. Juan is the founder of Protocol Labs. And similar to the theme that we have planned for the rest of the day, we want to talk about how things got started from some people and organizations that figure a lot of things out for the first time to now set the path forward for others to follow and learn from in this space. We're going to talk about how Protocol Labs, Filecoin, IPFS started, how they had to navigate through a lot of tough challenges from their initial beginnings, and how we can use all those learnings to think about what does it mean to start a startup now in crypto. So without further ado, please welcome Juan on stage.
Thanks for having me. Really excited to be here. Just always fantastic to meet a lot of the people in the ETHGlobal community. This is the strongest community in all of Web3 that is creating the future. So as we saw from Masa's presentation just now, secured finance and so many other major projects in Web3 have started in ETHGlobal hackathons and events and so on. So I look forward to meeting all of you and seeing what you are going to go and build. So that's what I'm here to talk about.
Stop. OK, well, I want to talk about a lot of how things started and what we can do to apply all those principles and learnings to people who are thinking about starting companies. Take us back to 10 years ago when you were at Stanford and you wanted to build a interplanetary file system.
Yeah, so I got into the crypto space fairly early. Like I had seen Bitcoin come through while I was a student at Stanford as an undergrad. I, along with many other people, mined a bunch of it in like computer clusters and so on. Lost all of it. Like I don't know where it ended up. Like probably some wallet file sitting in some old computer somewhere. And that was kind of like in 2010 or so, in 2009, 2010. But I'd seen many other cryptocurrencies come and go. They're just always remained fringe. And it wasn't really until 2012, 2013, when Bitcoin started growing a lot and breaking through a bunch of the barriers that I got more involved. So I'd been working on a lot of different kinds of things for a while. Like I'd been working in distributed systems. I'd done some wireless research. I had been always super inspired by peer-to-peer networks. I'd seen the successes of things like BitTorrent and Skype, and that showed enormous promise in being able to leverage all of the resources in large-scale networks. But it seemed like they always had these problems around markets. Like it was always kind of like a sharing economy structure that allowed a lot of freeloading, and there were lots of really great papers showing that the basic game theory of these systems didn't quite work out. And Skype was an especially interesting example because it enabled a whole massive telephony network at a massive company level to be built out of these peer-to-peer systems. And they used it by leveraging bandwidth in an uneven way. The nodes that Skype users ran in corporate networks ended up doing most of the traffic load, but none of those users got compensated because they weren't using a market structure. It was just kind of freeloading. And so that always struck me as something that needed to be fixed with a good market structure. But anyway, so I've been working on these kind of distributed systems for moving around information, and especially machine learning data sets. I was really interested in machine learning data sets are enormous. Moving around, even today, moving around models and data sets is difficult. And that pushed me to kind of combine a bunch of the ideas that ended up leading to IPFS, the Interplanetary File System. It was just kind of like hey, what if you could merge Git with BitTorrent? How hard could this be? Let's go build it. And 10 years in, like we're still like doing an enormous amount of work. But yeah, that's kind of like the beginning. And as Bitcoin was starting to take off, I wanted to kind of imbue the IPFS network with the ability to have a market associated with it. But it was very clear that these had to be two separate protocols, that IPFS and Filecoin had to be two separate things, because you wanted the ability to address and move content independent of the incentive structure. And so Filecoin began as a separate project.
Could you explain that a bit more deeply? Like, what does that mean as an example, and why is that distinction important?
Yeah, so IPFS gives you a set of rules for how you model data and how you move the data, but really enables any incentive to enable the data to move. So for example, you might use set of programs and software to move data just in your own computers. So you don't want to have to like transact with yourself and pay yourself for moving around files within your own devices. And sometimes you end up in sharing structures that work really well, and you want to just enable that kind of incentive structure to work. Or you might just want to be able to hire somebody without using crypto to store your stuff. So think of the normal centralized cloud systems being able to use content addressing and use the power of IPFS without having to use crypto. So think of IPFS as mapping to HTTP. It's just a way of kind of addressing the data and moving it. And then Filecoin is a layer on top of that that says, OK, great, like let's build a crypto incentivized network to back up all of your data and serve it to users and so on. So it's kind of like the equivalent of Amazon S3. It's kind of like a service that stores and distributes your data on top of IPFS.
That's very helpful. So my next natural question is, well, this is where we are now, but when you were thinking about all these things, did you not see what other projects were around? Like, why did you choose to start something on your own? Or like, what made you actually decide that I need to do this thing because nobody else is doing it? And what was that moment?
Yeah, so this was very early, like in 2013, Ethereum, 2012, 2013, Ethereum didn't quite exist yet. Vitalik was like crashing in my house while he was going around pitching Bitcoin colored coins to people and like just starting noodling on Ethereum. So it was clear that Bitcoin and surrounding projects were really powerful and had opened up the door to cryptocurrencies and digital assets and so on. And there was a couple decades of really good literature on what you could do with these kinds of markets, especially the Agoric papers from Mark Miller and Eric Drexler and others that kind of pioneered a ton of the thinking for what eventually our entire industry is making. But there weren't like breakthrough projects. I think Ethereum was like the first one that really started to succeed in a major way, like well beyond what Bitcoin and other surrounding projects plan to do. But kind of by that point, like the thing that sort of set Filecoin on its own path to be its own network were two things. One is the proof of work structure of Bitcoin is extremely useful as a way to collect tons of resources around the world. It's just that ideally you should be doing something useful and valuable. And so the kind of core consensus mechanism of Filecoin required the proof of work structure, but applied to having some useful work. So there's two answers to the proof of work is wasteful problem. One is get rid of it and move to proof of stake. The other is use that structure to do something really valuable and really useful. And that's kind of the path that Filecoin took. The other reason is like for a while we considered kind of building Filecoin as what we called a virtual chain. This is way before L2s were a thing on top of Ethereum. But then we calculated how many transactions we would need and the load that we would put on the Ethereum chain, and we were over all of the total Ethereum bandwidth capacity. So we just like that wasn't an option. So we ended up having to split out into a separate chain. But who knows in the future? Like my prediction is that most of these chains are gonna recombine in super interesting ways, and they'll like rehome. Like some L1s will turn into L2s, some L2s will turn into L1s, and it won't matter that much in the long term.
That's a very interesting. I want to dig more into that later. But so one side effect of that approach is that you basically have to figure a lot of it out on your own, and you've been pioneering a lot of R&D, a lot of massive open source projects like libp2p, and of course IPFS, and a handful of other. Actually, I want you to answer that. Tell me what you had to invent to get to here.
Yeah. So we tend to spawn a ton of projects. So Protocol Labs is well named, and that we just start investigating and creating tons of new protocols. libp2p is one of them. One collection of protocols that came out of IPFS to build like this peer-to-peer stack that a lot of other users could use. Now Ethereum is built on it. It's one great win after sort of like many years. There's other protocols like a more recent one is Drand. So Drand is a randomness beacon that's using threshold cryptography to give you secure random numbers. The Filecoin main chain is secured by Drand's randomness. And there's a bunch of other protocols that we built over time.
Space-time guarantees.
Yeah. Oh, yeah. So just in Filecoin alone, there were so many innovations that we had to build. So we had to solve this really hard problem in cryptography, where you want to be able to prove that a user, that a storage provider has a particular set of data, like files that they're storing for users, but you want to prove that they're not kind of, you want to prove independence of replicas, where you ideally want to hire the same source provider to store multiple copies of the same thing, or sorry, you want to hire many source providers to store copies of the same thing, and you want them to not collude and just store one, because you want redundancy in the network. And there's a bunch of different approaches to doing this, and one of the key features for us was that also made sure to use resources and was incompressible, and this is required for the consensus piece. And that led us down a path of proofs of space and proofs of retrievability, and eventually coming up with a new type of proof that we named Proof of Replication. And so there's a whole field of cryptography study now around proofs of replication that we had to invent that didn't exist before, that we had to come up with and had to structure in order to kind of do this. And as part of that included figuring out how to do these efficiently, how to apply zero-knowledge proofs to be able to do these at the throughput required for Filecoin. And so there's an enormous amount of kind of innovation and invention required in just getting the basics of Filecoin off the ground. Let alone kind of how do you create a market, like a storage market with deals between storage providers and clients, and how do you think about doing and maintaining those proofs over time? How do you enable lots of different data to be either commingled in different sectors and so on? So yeah, a lot of things got developed.
So the Carl Sagan quote of to create a perfect apple pie, you have to invent the universe.
Yeah, that's right. Yeah.
And, well, that's just on the technical stuff. There's a lot of things that you figure out on all the other pieces. Could you share some of the other logistical, legal, regulatory, corporate, all those things that you basically paved the path for the rest of the ecosystem, and what went into all those decision-making processes?
Yeah. So in 2016, 2017, we had to sort of chart a pathway to being able to. There were a lot of kind of public token sales and so on happening. And it was really not clear what the regulatory status of them was. I think even today, the world has been ping-ponging back and forth between clarity on this and so on, and especially in some areas it still remains pretty unclear. But we had to sort of thread the needle between a lot of concerns and try to find a really solid and sound way to do it. And so we ended up having to do a bunch of legal research and ended up inventing a thing called the SAFT, which is now an instrument that tons of other organizations and networks have used to sort of fundraise to be able to launch their networks. And then we had to build an entire fundraising platform that the CoinList. I'm sure people have probably heard about it or seen it. And that entire thing got invented and built at PL as part of launching Filecoin. And so yeah, there was a lot of innovation.
All you wanted to do was store files.
Exactly. All I wanted to do was to move around some machine learning data sets with Git version control level of fidelity. So.
Well, I think it's wonderful because now those have become somewhat standards and people get to use it. And this is a perfect segue for us to talk about what somebody starting a company now doesn't have to do or figure out. And what I want to do is kind of start off by kind of getting your take on what is the current opportunity in this space. Are you still excited to build things in Web3?
Yeah.
Has everything been invented yet?
So look, I think there are two big things happening in. The two most important movements happening in the world right now are the AI machine learning movement and crypto and Web3. So those two areas are the most transformative branches of all of what humanity is doing. And I say that because they're going to radically reshape how our entire social structures and economies and organizations work. So sort of the leverage there is taking the nth derivative of everything else. It's you end up having super powerful primitives that end up reshaping how so many other fields or industries or groups of people are going to organize and do things. And so it's an extremely exciting time. The way I sort of think about Web3 and kind of where we are is that for a bunch of reasons, some of them technical, some of them social, some of them kind of product-oriented or economics-oriented, crypto and Web3 have taken a lot longer than, say, Web2. And it's sort of a closer, Web3 is kind of ending up closer to kind of the Web 1 and Web 2 segments put together, in that the way I sort of think of Web3 today is kind of like the 97 or 1998 era, where you had seen a bunch of things that sort of worked and scaled and worked, but everything is still like really janky. Like things still don't work super smoothly. Things are really slow. Like I don't know if you raise your hand if like you tried using the internet in like 95 or 97 or whatever. I don't even know how many people weren't alive at that point. I'm old. So if you remember, like this was like pretty painful, right? Like you tried to load a web page and it would take a while to like stream down and load.
Line by line JPEG render.
Yeah, exactly. Like line by line JPEG. You try to search for something and you had to go to like page 16 on Alta Vista or something. And it was just awful. But yet it was so magical and powerful, and everybody kind of saw how powerful it was. It was just not quite there, and it was not at all obvious what it would be like. And this is like pre-smartphones, pre-iPhone, pre all the social networks, pre the big search engines,
pre-DSL,
pre-Amazon. So all of those really major things that we now see as like the internet giants came way after that. So I think in Web3 we're kind of in a similar time period where a lot of the really important breakthrough things are going to be built over the next 5 to 15 years. Not like the next 2 or 3, 5 to 15 years. We'll still see major things being built 5 to 10 years out that are going to reshape the world.
So let's dig into more of that. So is that an argument for you're saying that things just need to be faster, or we just need better or safer infrastructure? Or are you saying we haven't seen some primitives that we will invent that will end up letting us do more things creatively?
Yeah, I think it's a lot of things. I think it's major things in the infrastructure have to improve. So one of them is scalability. Like analogous to the Web 1 era, things have to get really fast and really smooth. User experiences have to get dramatically better. You know, the Web 1 user experiences were pretty terrible. The Web 2 user experiences got dramatically better. Accessibility needs to improve a lot. People couldn't predict that the web was really going to change once people got the smartphones. Like there was a huge shift once smartphones got diffused. All of the web applications and web services grew dramatically. Like they went from tens of millions to then suddenly hundreds of millions or billions of users, and with lots of activity daily. And so the notion of putting the internet in your pocket, we need some kind of equivalent thing to that for crypto, where accessibility has to shift from how it is now to some like dramatically easier structure to then enable billions of people around the world to use all of these primitives. Like what we have today is like just not good enough. There's a lot of work to do there. And then beyond that, I think that there's lots of different applications that are use case specific that haven't been invented yet. So things like things like Netflix and all the social networks and so on, like all those were answers to concrete problems and concrete product instantiations. We'll have a whole wave of things like that in the Web3 and crypto space. We still don't have super strong Web3 social networks yet, right? Like they're just starting. They're still very small. They're still like kind of clunky. Like they don't work perfectly. And so those, once they arrive, they're gonna radically shift how things work. And we'll see a whole bunch of other kinds of applications like that. I think games are an interesting area where I think we now have the right primitives to be able to build some really compelling game experiences where the currencies and the smart contracts and so on have a strong reason to be there, where like the governance of these worlds, of these virtual worlds, can be done like well and correctly and according to the community playing the game. And so I think those environments are kind of like we're just now reaching the cusp of them being possible. So I think that there's going to be a lot of stuff there.
You've kind of already started talking about this thing, so maybe let's talk more about what are some other interesting themes or opportunities in kind of the subcategories that you see that either are under addressed or things that you think are just too crowded that people should not spend too much time on. Second one is a bit harder, but I'll let you start with the first.
So I think I'll speak maybe like a lot of the problems that I know a lot about, and then maybe some about things that I know less about. So I think on the infrastructure layer, we still haven't seen the kind of like data transfer networks really take off. So we have Helium, and like that's probably the strongest one. But I think we're going to get to build infrastructure that is going to enable all of the connectivity for like the lower layer of the internet to be governed by smart contracts and crypto primitives. And just the utility of just replacing the old way of doing things with this structure is just dramatically better. That plus like wireless mesh networks or satellite networks. Think of like a Starlink type of equivalent, but that's crypto powered and crypto financed. Then things like getting to chain scalability. So today, we're reaching for tens of thousands or hundreds of thousands of transactions per second on each chain. We need to be reaching for billions or trillions of transactions per second. That's the real benchmark. The moment where you can have something like all of Twitter built on-chain. Not off-chain and do this like super complex dance of like off-chain and on-chain data. I'm talking about all of Twitter. Every single tweet, every single like, every single view and recording that there was a view, all of that state tracked with the certainty of a blockchain. That's the kind of scalability that we need. And most people would be like, that's impossible. Like, no, it's totally possible. Scaling laws work. The current centralized cloud systems have structures that are similar, and they make it work. It's just a kind of nuanced way of how you get to it. So I think like there's lots of stuff in the infrastructure layer. Then kind of more in the applications area, especially around, I think there's a lot of opportunities to build really strong computational networks around data. So we haven't yet seen lots of applications where you can run arbitrary compute jobs over data. So think of things like Amazon Lambda or EC2 or Kubernetes and so on. Like those projects are just beginning, and those computational networks I think are going to be big this year and next year. I think we're going to see a number of projects start in that area. Some of those will have zero knowledge involved. So think of like zero knowledge Amazon Lambda style things. There's a project called Lurk that's aiming to do this, like ZK Lambda. And there's a project called Bacalao that's trying to do kind of like this compute over data sort of stuff. But there's going to be many of these kinds of networks. Just think of being able to do everything you do today in like the normal cloud systems, but in a crypto-powered way. So that also includes databases. Nobody has really tried hard to do a crypto-native database from scratch. What does it look like to build a super scalable database with like SQL level capabilities, but all over crypto data? Like once we have something like that, you then are able to build all kinds of other applications on top, and it becomes easy to build things like Twitter.
So I guess out of curiosity, what would be the features of a crypto native database that's relational or?
Yeah, so I think it depends on how you could always build it like non-relational inside and build relational stuff engine, on top, or vice versa. What you want, like, there's just the standard traditional database semantics of like ACID, which is atomicity, consistency, integrity. Forgot what the data is. Data availability, maybe? I'm not sure. Database people
ACID
hold me
compliance, yes.
Yeah, exactly.
We'll edit this out.
Plus, you want like very large scalability. So you want to be able to have the same kind of semantics as Bigtable in Google Cloud or other similar databases, where it really is infinitely scalable. You just scale to as many machines as you add into it, and with low latency retrieval, so and low latency consistency. So you should be able to write to it and be able to read out with consistency in less than a second. And so like that's hard problem, especially at high scale. But if we can do that, then you can build things like Twitter or all of the social networks, games, entire virtual worlds, and so on. Because if you have those primitives underneath, you can layer all of the other SQL-like semantics on top, and then you get to translate all of the stuff that people have built so far in kind of the Web 2 world directly on top of Web 3, and now you can have the Instagrams of the world and so on be fully powered by Web 3 primitives. So I think that area is like, I think, super, super important.
So when you talk about something like this thing, are we compromising on things still being decentralized, or is it just the fact that we distinguish on-chain, which to me is more of a comment on auditability versus it being an open network?
No, I think that you don't have to compromise on this being sort of off-chain or on-chain, or you don't have to compromise in decentralization. I think the way you get to super high scalability in terms of throughput and low latency is that you apply just zoning and regions to the problem, and you model the cost and risk of being in a region that's very small. So I'll describe an approach that we're taking.
Data centers.
Yeah, exactly. So you sort of like you have to match the structure of physics, right? At the end of the day, like whatever virtual world model you have has to leverage the utility of the physical world. The way that we think about it in IPFS is, I think, called the interplanetary principle. Like your network should work just as well between Earth and Mars as it does between a phone and a data center and so on. And so just because you have a system, like you shouldn't have to wait until a transaction clears in Mars to be able to use it while you're on Earth, right? Like that's a 4 to 8 minute delay depending on the year, on the time of year. And so like that's just totally unacceptable. And like unfortunately, that's where blockchains are today. You have to wait 4 to 8 minutes. It's totally bogus, right? And so we need to get dramatically better here. And you can do this by breaking up into regions and connecting these things so you have different levels of consistency depending on where you're writing and reading from.
So we're talking about interplanetary and intraplanetary file systems.
Yeah, exactly.
At the end of the day.
Yeah, so funny story. We're working on a project trying to tackle some of these things called interplanetary consensus. And we didn't start with that name, but we ended up like renaming it that way because it just sort of like fit the model of like, oh, you should be able to have consensus on Earth and like, Asia and Japan and Tokyo specifically, and just kind of think of a fractal structure.
So let's focus on the founders here. What do you see as an opportunity for founders to build interesting companies in Japan?
So yeah, great question. So I have a ton of affinity for Japan and Japanese culture and so on. I sort of grew up with lots of different aspects of Japanese culture influencing me and like my life and so on. Just massive amounts of creativity when it comes to things like all of the different games, all of the different media, stories, dedication to like excellent craftsmanship, extremely good experiences. And so I think right as crypto's getting into the cusp of being able to do games, this is a moment where that whole skill set that has been well honed in Japan could be massively applicable. And so we're talking about building next generation games and virtual worlds and so on that are now Web3 and blockchain powered. So I think that's one whole area. Another area I think is around DeFi and just all of the areas of finance. As Masa was just saying, like most of DeFi today is just about one small segment of money markets around kind of like simple loans. We haven't even touched all of the other kinds of stacks of financial products that could be built. And the things that can give a great capital stack for organizations and corporations and so on. So Japan has a tremendously rich history in terms of creating structures for organizations, has some of like the most successful companies on the planet, many interesting ways of organizing like the keiretsu, which is a structure for corporations that are related to each other in a large supply chain. Like you can model all of those things with crypto, and you can do that across borders and with a new kind of jurisdiction. So I think everything relating to DeFi and just the capital stack, I think Japan could be extremely well positioned for. And then other kinds of media. So of course, all of the kind of music and video production, all of those areas are super rich and vibrant in Japan. And I think that could be a super strong area here too. So this translates well to NFTs and maybe even mixing with generative AI, where you think of being able to enable creators with just super powerful tools to be able to create media that is super compelling and super interesting to experience. So yeah, I think all those areas are super viable for mixing the skill set. Now, of course, Japan is also great at a bunch of the other things. So there's just some that came to mind.
You usually talk to a lot of companies or founders that are thinking about starting companies. What are kind of common things or patterns that you notice where either they're stuck or you want to kind of tell them that they shouldn't spend extra time on this one versus focusing on X? Any general advice we can start off with, and we'll kind of focus on what specifically applies to Japan.
Yeah, so I think, so maybe speaking generally first for a moment, and then we'll sort of think about Japan specifically. When starting a new project that can turn into a startup, I think it's pretty important to do a couple things. One is learn an enormous amount and just become a super learner where no matter what problem you might be facing, you have to get really good at figuring out how to solve it, how to look up online how to solve that problem, and then doing it. And just kind of being able to do this on a really fast iteration loop is I think, one of the most critical entrepreneurial skill sets that you can develop, because you will face thousands or tens of thousands of problems, all of which are themselves not that hard. Some of them might be hard, but you just have to figure out how to solve them just good enough to kind of move on and solve the next one. So I think that's one key thing. Then when you think about projects, just think about I tend to sort of like model this as a pipeline where you kind of start by kind of in early stages thinking about potential ideas, and you're kind of bouncing around ideas either just yourself or with friends or colleagues, and you're thinking about potential things that could turn into compelling projects, or you're just playing around and hacking on something, and then suddenly you realize that something is valuable, just kind of be open-minded and explore a lot of possible paths, and keep kind of breaking down why they may or may not work. And you kind of want to get to something that just feels super compelling, that you can see will work, and seems maybe counterintuitive. It's just kind of in the cusp of, it's not going to be super crowded, so it's not so obvious that there are 1,000 other people trying to do the same thing, but not so rare and difficult that it's going to be almost impossible to pull it off. And so there's kind of this sweet spot where it just became possible, or maybe you have a nuanced approach or kind of a secret on how why this might be really valuable and really possible now, or an approach on how to do it. Like that's kind of the sweet spot of an idea that maybe has a potential has legs, and you want to think about kind of the scale of where it could be, where it could apply, right? So some projects have small scale, some projects have large scale, and you should decide what kind of project you want to build. Like startups are meant for really fast, large scale types of things. There are other really valuable projects and contributions that you can make that are not startups, and so just how you approach your project sort of depends a little bit on the scale. So think of like an indie game. I would say something like Minecraft, massively successful, was not a startup, right? At the very beginning, it was kind of like a labor of love that, and the approach that it took to build something like Minecraft was not the same approach that you would take to build kind of a startup-oriented project. And so I think like figure out what kind of project you want to build to then follow an approach that might work. Once you kind of experiment with ideas, you can get into kind of like trying to build early prototypes and early versions. This is where hackathons are crucial. Hackathons give you the opportunity to build a thing in a limited time. You don't have time to kind of like make the perfect version. You have to do something by a deadline, and then you have to make it compelling to other people. You have to like make a thing that other people will look at and say, oh yeah, that's interesting, that's cool, like I kind of want to try that. And so hackathons give you this perfect version of kind of testing out your idea. You have to build a thing end to end. You have to be able to sell it to other people in terms of sell the vision for it, and you have to present it well. And it has to work. It has to be a demo of like something that you could actually use. And so once that, I think hackathons are a great way to try things that might turn into startups. And then from there, you can find something that could be really compelling, and you can decide whether or not to kind of pursue it further, and then go into deeper validation of saying, hey, is there actually a product here? Could this serve a market? Could this get into could this turn into like a minimum viable product that a lot of people might want to use, to then turn into a larger project that you could then spend many months or years of your life actually building. And then from there, you have like now what could make a startup.
No, those two. This actually segues right into my next question, which was, I think oftentimes people misunderstand what MVP means. Could you share more about what is a good framework to understand what a minimal viable product is and what it isn't? But also, if you are in a position where you kind of feel like you have something or 10 people really like it, how do you know that this is worth spending time on?
Yeah, so minimum viable product, right? So it has to be a product. It has to be a thing that you can point to and use, and it's going to like do something useful for somebody. It has to solve a problem for someone, and hopefully for a lot of people, but ideally for a small community at first. It has to be viable, which means that it has to be able to solve the problem well enough that people want to use it. That bar is actually surprisingly high. The viability thing is actually quite hard to get to. Once you have that viability, you can sort of like see it and measure it by when people try to use the product, they start, they really kind of have to keep using the product, even though it might be like really ugly or janky or painful, even though it might have like huge gas fees, or like be very hard to use and painful. It's just like so valuable to them that they have to keep using it. And then kind of like a minimum part, it's about letting you relax and not build like the maximum viable product or something that's really hard to build. It just forces you to just get enough of the bare bones right. So I tend to approach this by trying to build a minimum product that's not yet valuable first, like just a very bare bones end-to-end thing that has just enough of each component to actually work. Often this might mean like a good facade, but then the
like
back
a
end is
hackathon project.
Yeah, exactly, a hackathon project. Interesting story here. Stripe was first like this really nice front end, in front of another payment processor behind the scenes. And so it had like, it really was like a minimum viable product, and they had just gotten the right experience, but everything underneath, like they hadn't built out. But that was good enough to get started. And so I think of it kind of like that. You build a thing end to end. You don't let yourself try to get to completion on anything, because it's going to take you so long. It's going to take you months or years to build that. So instead, you kind of want to time bound it and say, what can you build in a weekend? What can you build in a week? What can you build in a month? That will be kind of like good enough on several aspects to just get close enough to solving the problem well enough for a group. Like initially, you might solve your own problem. You might solve a problem for yourself or for a community that you know really well. And initially, it might be such that like you're solving the problem for 1 out of 1,000 people. That means like 999 people just don't want to use the product well enough yet. But that one person like sees the promise in this thing, and that gives you a hook to then be able to expand that from a minimum product into a minimum viable product. And that difference is once you start getting sort of like a threshold or a percentage conversion in people experiencing the product and wanting to stick with it and wanting to use it. So once you sort of like reach kind of like a some percentage that's really specific to each product. Like products vary in their conversion rates. Like something like a social network has a much higher conversion rate than I don't know, a more dedicated product like
a finance app
like a finance application, or even like a sharing economy, like a ride-hailing app or something like that. So it's really kind of tuned to what viability means is tuned to the product. But you really kind of want to start with a minimum possible thing, and then test it, figure out, try it with users, get feedback from them, like ask like 10, 50, 100 people to try it, and give you feedback, and then integrate the common feedback and address that first. Like initially, people will give you 10 to 100 points of feedback. If you address all of them, you're going to take too long. Instead, kind of ask a bunch of people and find the common things and solve those first, and keep trying. And eventually, you'll get to like a sweet spot where suddenly it kind of passes this threshold of utility, where suddenly people start sticking with it and say, oh, like it's still not great, but now it's sort of like good enough for me to actually use it and actually solve a problem that I have. And that's when you start getting product market fit. And the deeper you go into that, and the more and more people want to use it, you have like stronger viability, and you have stronger product market fit. And like that's the difference between kind of an early hackathon project and something that is now kind of startup ready, is finding that kind of like minimum product to like starting to have the minimum viable product. Many startups start before they truly have something with great product market fit, but they have kind of like an early version of a minimum viable product, or at least kind of like a very strong concept for one. And that's kind of like the sweet spot for when you can really start a startup. And then from there, like the first year or two usually is about getting to that product market fit, so you have built precisely what the market needs to be able to actually solve their problem.
I think that's really good advice in terms of just a good framework to think about it. You've been part of Y Combinator, and there's a lot of things that they instill on just make something people want.
Yes. That is such sage advice, by the way. Like it's just kind of baffling how amazingly simple and straightforward and good advice that is. Make something people want. Like it's just as simple as that. Like this is like the most valuable piece of advice about building a startup ever. And you have to make something that people want. Like when they get exposed to it, they have to like, it's not just that they might need it, they actually have to want to use it. They have to like want to seek it. And like that is really key. Sorry, interrupted you.
I guess the one challenge that I think we face in our space is oftentimes compared to kind of Web2, we don't really have a lot of exact mappings that apply. If you end up inventing a 100x runtime multiplier on some ZK computational thing, maybe you can figure out a way to kind of how to productize it. But if you're playing with some new primitive or just a new concept of like I gotta now tell people what a new organization type is, you don't really have a lot of things to learn from. So what advice do you have for founders where they're in a situation where they have to decide between figuring it out on their own the hard way and seeing if they get to create a vertical or a new industry versus just copying something that someone has done before or just repeating something that they've seen work in this space? And is there a good framework that you have to think between those two?
It's a great question. So the way to sort of think about it is like think of it like an optimization problem, or another way to put it is like think of a large surface like a landscape with hills and valleys and so on. and sort of like the world is stuck somewhere. Think of like water. And you can imagine some way in which the world could be better, and you can kind of visualize a different valley where like the water wants to flow down into. But there's a bunch of activation energy in pushing like the water up a hill so that it can flow down, or in like digging a valley into the mountain to be able to allow the water to flow down. And all that takes effort. If there's a huge mountain range, it'll take you many months or years to like tunnel through. If it's like a small enough thing, it might just not be obvious to a lot of people, and you have stumbled into a secret. Or there was like a huge tectonic shift that suddenly made something possible, and not a lot of people have noticed it yet. And so just think about it, visualizing it that way. And because in some cases, there might be a lot of effort, but the world will be so much better that it's worth taking on this huge amount of effort to do it. In other cases, the world is not going to be that much better, and it's going to be a huge amount of effort to do it. So like, don't do that. In other cases, you'll find like small amounts of effort that will get you pretty far. And kind of the best model here is to kind of think of ways where you can like tunnel down to like a slightly better world and bring a community with you, and then keep doing this iteratively. And that's kind of like recruiting different user bases or communities that will help build something over time. And so, you know, the space of possibility is really large. You could build a new, you know, ZK acceleration primitive or something like that, or a fundamental new branch of cryptography or computer science that might take 5 to 10 years to take on. But the value there could be just so big that you should just go and do that. But you have to kind of understand and visualize why it's going to be so compelling and so valuable down the road. Like the early zero-knowledge proofs work, you know, 10, 20 years ago, the authors and inventors that knew and understood this was going to be a really important primitive down the road. It just maybe took a lot longer to realize than they may have expected.
You can be off by decades sometimes. And,
yeah, decades, centuries sometimes. Like the key math enabling pairing cryptography.
Just like the fields.
The field stuff, and it was like early elliptic curves came from like early Greeks, and then the veil pairing was in like the early 1940s or something, or like around then, and it wasn't used until like early 2000s with like BLS signatures, and then eventually in threshold crypto and so on. So like it's not always clear how something is going to end up being really valuable, but especially when you're in the realm of startups, you have a short timeline. You don't have a century for this to take on. Like that's not a startup. That's more academic work or creating a movement or something like that. When you're building a startup, you have a very short limited time. You have months, maybe a year or two, to get the thing working well enough. And so you have to kind of pick your problem well to know that you're going to have enough traction and success to show value to a whole community, such that you can then kind of either raise funding to then kind of build a product, or you can start, which is even better, get early revenue that can then funnel and fund the creation of this. One really cool thing about crypto is that our community understands the value of public goods way more than many other communities, way more than kind of all of the private venture capital world. And so you can now create the equivalent of kind of public goods-oriented startups in our community. This is super new. This is not a kind of traditional tech thing. This is not a traditional Silicon Valley thing. This is very different. You can now create the equivalent of startups that are building public goods funded at those scales. It is super new, super interesting. It's just kind of, like you were saying, new kinds of organizational structures, not quite a lot figured out, and you're going to have to be like solving a bunch of side tangential problems along the way. So it's kind of new and valuable, but you're going to have to spend a bunch of energy on defining new things. Like all of the groups doing DAO-oriented things. Like building DAOs is very different than building companies, and it comes with different kinds of challenges, some benefits, some negatives, and it's just a different thing, and it's not a well-trodden path, so it's not really well figured out. And so if you choose to go that path, you have to understand like what you're getting yourself into and why it's better for your particular thing. And same goes for any kind of new organizational structure. When you're building a startup, you want to kind of limit the amount of time that you're going to spend not solving the core problem, because you're going to encounter so much stuff to do that you want to kind of try and severely limit the amount of effort that you have to put in to get really successful things. Now, in some cases, it might be really worth it. Like a new organizational type is sort of required for your thing. But only do that if it's really, truly required. If it's a nice to have, you have to cut it. Like prioritize your time and be able to cut out the things that are not essential.
If anybody has any questions for Juan, please line up here. We're going to start taking a few questions in a minute. One question before we go into the audience is, at this point, the space exists, which wasn't true 10 years ago or even 7 years ago. You had to still explain to a VC what blockchain is, and now we have a whole separate new world.
I remember having to go around pitching people on like, oh yeah, we'll create a currency and we will take a stake in that currency, and then that'll be valuable. And like that was like seen as I was crazy. I remember having conversations with A6 and Z of all groups, and that was like a foreign concept at the time.
But we're no longer in that world. What are some resources that founders can take advantage of now to actually, anywhere from bootstrap to kickstart this process of starting companies in Web3?
Yeah, so I would sort of map a whole bunch of programs associated with the pipeline. So first off, hackathons, I would start there. This is a great place to try building your things and just experiment, build, try out different products. Eventually, you'll find one that you think is really compelling. It could be different takes on the same idea, or it could be a bunch of different ideas. Hackathons also help you connect and find other people that you might click with and form a team with, especially in the remote world, and especially in Web3. Hackathons give you a really good equivalent to what might have been classes in a university or something like that, which is kind of like a common way by which a lot of startups get started, kind of like classmates that got to know each other. You can have the sort of similar kind of experience in remote communities of developers and builders that get to know each other and get to build with each other online. So hackathons first. Then after that, I think this area is not really well served. That's the kind of like going from the hackathon to the early startup. This area is where you're trying to kind of test the viability of something and validate the idea. This is where there are a bunch of grants. So we at PL run a program called Next Step Grants for projects kind of that are post-hackathon phase but before accelerators, to just help give people small grants that can enable them to kind of work full-time on this thing for a few weeks, just to see if that'll be strong enough to get to startup. After that phase, that's where accelerator programs exist, where you can kind of apply to an accelerator and you give some amount of equity of your idea for some initial funding to be able to work on it full time for months at a time and to validate, help fundraise, turn it into a proper business or company or network or protocol or whatever you end up doing. There's a number of different accelerators that can apply to you. A strong plug for Graph Paper Capital, I think, is a new accelerator that Gabe, who used to run Tachyon, just started. It's a super compelling project. Gabe is phenomenal, has helped tons of founders in the space, has helped Masa and so many other groups in the ETHGlobal community. And also Longhash. It's a number of other accelerators that are in the space and that are doing tremendously good work. And so I think of those as the three categories of programs. Like first, hackathons. Second, kind of grants to help tide you over to help get to kind of accelerator stage, and then accelerators. Now from there, like that's when it's a whole other set of stages around kind of fundraising for different rounds, like seed, Series A, and so on. And the equivalents in the crypto world, which don't map to that exactly. But those are kind of like way later. So like don't worry about any of that now. Just kind of worry about these first initial three stages, like hackathon readiness, validate the product, and then get to kind of like accelerator stage.
Awesome. Let's go to some of our audience questions.
Thanks, Juan. Jeff from Curve Grid, super fascinating. Thanks for sharing your thoughts. If I think of public goods and decentralized storage, IPFS, Filecoin, I mean, one example, of course, is the Internet Archive, archive.org. And we heard at DevCon last year, Brewster Cowell, the founder of archive.org, talk about some of their experiments with IPFS. I guess looking to the future, like, what are the things that it would take to kind of, the innovations or the things that need to be developed to be able to put the 99 petabytes of archive.org data on IPFS? And then even looking further than that, like if we think even further to the future, where do we go from somebody like literally AWS with S3 moving from their proprietary backend, much as companies did, move from proprietary operating systems and networks to Linux and the internet. What would it take for AWS to move all of S3 onto IPFS in the future? And the question is around, again, innovation and start, like, maybe it's not Protocol Labs that builds that, but what things could maybe future founders be building along that roadmap?
Yeah, there's like three to four questions there, so I'm gonna like maybe answer a few.
On one.
So maybe first on the Internet Archive one. So the Internet Archive is one of the best public goods on the internet. It's like this phenomenal service and project and community of people who are helping us back up all of the important information on the internet, and tons of books and other media as well. So it's an amazing library of content, providing free access to all this public knowledge for all, for free, forever. It's just an amazing public good. And yeah, so we've been working with them for, actually, just when I started IPFS, I immediately went to talk to Rooster about all of this, and he was actually super helpful in helping guide me and other people in our community in how to navigate the landscape. So we're actually doing what you just said. We're already onboarding the Internet Archive itself, the entire, we're going to onboard the entire thing, but we're starting with smaller segments. We're onboarding chunks of the Internet Archive onto Filecoin, and from there providing access to all of that data through IPFS. So that's, we also want to make sure there's many replicas of all of the archive's content in a bunch of places in the world for good redundancy reasons, good faster access in certain areas, and so on. And so yeah, that project is ongoing. The next part of that is kind of getting the entire interfaces and UIs and so on to shift. Like that's a much harder problem. Just moving kind of the data and making the data accessible is like step one. Step two is kind of like reshaping the applications and whatnot. To your other question about AWS and so on, I don't think it's likely that AWS itself would switch over because they really enjoy the having that as a business. It's kind of like would like Alta Vista has switched over to Google or something like that, right? And like no, like the answer is like they didn't want to kind of give off. It's directly competitive, and so it is possible that eventually they might be able. It might make sense for them to do it and build a layer on top, but I don't think that'll make sense for a long time. I think what's much more likely is that users of S3 migrate off because the cost of S3 actually has a very large margin. Amazon really likes selling this idea that there isn't a margin there and that they run everything down to like the bare minimum, and that may be true in some parts of the business. Definitely not true in
storage or
AWS.
bandwidth.
Yeah, definitely not true in storage and bandwidth. Bandwidth especially, like they charge through the nose for any kind of egress fees. Like just yeah. So I think that just not having that kind of egress problem is just one of the biggest selling points for people wanting to use Filecoin. Like so many of the users that have lots of data come to Filecoin because they think that's egregious and they don't want to pay that. Right.
Awesome.
Thank you.
We'll go to the next question.
Hey, I'm glad we shifted a little to mentioning public goods, and I love that you mentioned that it's a very Web3 thing to build public goods and feel like there is attention being paid to it, and there is some funding that's funneling down to it. So I specifically want to ask about hypercerts. Like, how do you envision hypercerts playing a meaningful role in this, and what do you want to see built on top of hypercerts?
Yeah, great question. So for everyone in the audience, hypercerts are a specific concrete instantiation of a thing called an impact certificate, which is a way of like describing a certain impact and creating a token associated with that, or like a concrete object that you can associate with that impact. Think of it kind of like how currency bottles utility. Think of a hypercert as bottling impact, and making it tradable. So for example, you could go and like plant 10 trees and then mint a certificate that you have done that, and then you could sell that. And so if you need money to eat, you could sell the fact that you've planted 10 trees as a public good to somebody that cares about that. Not everyone's going to care about that. Not everyone in the world is going to want to pay you for planting 10 trees. But some people will, because some people really care about public goods, and certain communities, and especially governments and nation states might really care about that. So I think like hypercerts is one of the most important innovations in the entire space, and I think it's which is kind of like why we're spending a lot of time and effort working in those projects. And it has an enormous amount of potential, and I think it's very early days. I think the kinds of things that, and you can think of carbon credits as a special case version that worked at scale in the world, in the kind of traditional finance world. Just hypercerts should work in a very general way. I think what we need right now is, we now have the standard, we now have implementations of the early versions. We just did the pilot with Gitcoin. I think the next things that I think will be important is finding something where there's a community that really cares about funding a certain set of work. Like there's a set of buyers of these hypercerts, and there's a set of parties that want to do the work. And where these two communities are different, where hypercerts are really enabling that market to form, like that impact market to exist. And so I wouldn't go after carbon credits because that already exists, and it's very difficult to kind of shift that over. I would find some other area where there's people that want to cause certain good, and then there's people that want to do that good, and they don't have the resources to do it. And so like that creating a market just for that, I think could be extremely, extremely useful. And then just helping popularize the idea. I think we're very early stages here, and so I think just helping a lot more people know about it would be really good.
All right, so if you contributed to Web3 Beach, we were the first project to mint hypercerts on Optimism. I'm really stoked about that. So go claim your hypercert if you contributed.
Awesome. All right, next question.
So thanks Poco Labs for all the innovations. So my question is, how is fundraising different for like public goods oriented startup? You mentioned like Y Combinator is super successful, but then there's definitely like pros and cons for VC models for like Web3 startups, right?
Yeah, great question. So most startups work through private capital, right? So that means money and other financial instruments for the private gain of individuals and small organizations or like funds or kind of groups of people. We need an equivalent for public capital. So public capital exists. You have nation states with massive amounts of public capital being donated to and run and allocated through huge institutions that fund tons of organizations on the planet. Like we're talking hundreds of billions of dollars a year or
government grants.
Yeah, like take all the budget in all of the governments and union it, and like that's public capital. What we're missing is the in-between layer of how do you go from these massive scale capital to the individuals or small groups doing the work and building better rails that are kind of like similar to how venture capital works. And so we need the analog of venture capital to exist for public capital. At PL, we think about this as, we call it network capital. And so it's kind of like venture capital, but network capital of helping networks organize a subset of their resources and fund things that are good for that network. And so it's very localized in terms of it's the pool of resources of a network for the purpose of improving that network. Because that's a public good, right? A public good is not for, it's hard to imagine a public good for everyone in the world, except maybe energy. Or sorry, not everyone in the universe, except maybe energy. Public goods are really localized to a network. It's like they affect a specific network or a specific group more than they help others. And so that network usually can pay for the provisioning of that public good. And so that's where we need to kind of invent a stack of like funds. We need the equivalent of like an early stage VC fund or a seed fund.
Like a better co-op structure to kind of help self-sustain.
And we need like the equivalent of carry. So you need the equivalent of being able to profit from doing good public goods allocation. And like we need that primitive to exist and to be normal. We need to make it to be normal and good for people to profit a lot from doing good work. Like today, for whatever reason, the world kind of split into like private capital, you can make a lot of money. Public capital, you must make no money, and like you must have no money. If you have any money, like you're clearly bad, and like that's a big mistake. I think that we need to enable the world. We ideally should make it more profitable for people to do good work for the world, right? And so like we want public capital to be more valuable and more profitable for everybody, and that'll cause a lot of people to do more good things. The hard part is kind of how do you check that something is really good and really legit.
Awesome. Let's do our last question, and then we'll move on to the next presentation.
Thank you for such inspiring talks. A lot of my questions were actually addressed by the other guys, so I want to ask another one. I'm a huge fan of Douglas Engelbart and intelligence augmentation, and so I wonder what kind of capabilities you might like to see most augmented for the benefit of humanity.
This is a great question, and Doug Engelbart was super influential to me too. Read a lot of the early works. The demo was so influential to me. There's a thing called the mother of all demos. It's on YouTube. You can go watch it. It's like super influential. Early 60s work. Showing like the beginning of a lot of the personal computing stuff. Stuff that, including video conferencing with many parties, like multiple cursors. Like Figma was like the first.
From a van.
Yeah. Figma is like finally like realized that part of the Doug Engelbart vision. 50, 60 years later. So that demo was so influential. Highly recommend that everyone go see it. It's like an hour or two. So important. So Doug Engelbart wrote these amazing set of papers, also go read those, about really the promise of computers to greatly augment humanity's knowledge and ability to coordinate. And so it was all about kind of like augmentation of human coordination and knowledge and so on. And he had a thing called like the DKR, like the dynamic knowledge repository and so on. There's lots of really good ideas, so I would even start there. Lots of those ideas have not yet been realized, so that's a great area. What I would like to see, so what I tend to think about now is that there's probably two veins, I guess 3 veins of things. One is like all of the machine learning and AI methods, and there's going to be a ton there. But I'm going to leave that out of this discussion because it's probably really well covered by Twitter threads on GPT-4 right now. Just there's a lot of there that I kind of would want to talk about. There's a second area that they'll talk about more, which is around brain-machine interfaces. So a really big problem is between how we interface with computers. Like the keyboards and screens are just too slow. We now need to break that barrier and be able to interconnect with computers much faster. And so everything relating to like how do we break that barrier, I think is super critical. So this means funding work for being able to see a much greater density. So like either think of like implants to do like vision of digital media, like kind of like full virtual world level type of media. So input and output. And then the other output is like how do you interconnect the brain to computers to be able to do output at a much higher rate than typing with your thumbs or whatever. I think like those two things are going to be the brain-machine interfaces has the most promise in ensuring humanity's survival. Like I'm just going to describe it that way. And then the more crypto and Web3 oriented stuff is, I think there's just an enormous amount of potential for better coordination primitives with really easy to use interfaces. I'll throw an idea that I've been thinking about for a while. So Twitter, the value of Twitter is that you have one platform that a lot of people use that's running the same exact software to visualize the thing, and everyone has relatively the same experience using the feed, and it has a ton of people in this like highly constrained environment being able to process tons of information, right? It's a hive mind. Twitter is like the productized version of a huge hive mind, being able to have small headlines to then be able to click more and see threads and to kind of signal boost ideas. So it's like our first, not our first, but like a very valuable collective brain. What Twitter is missing is the way to now turn that into stronger action. So today you can do polls. Polls is like, polls, likes, and retweets are like the primitives that you have to be able to interact in that hive mind. You can click a link to another interface, and that sucks. Like the conversion rate on that is terrible. Almost nobody will click through and go do something else. Instead, what I would really like to have is a Twitter where you can embed a widget that has some capabilities, and you have some restrictions on what you can do, but you have much more expressibility, and you make that programmable, so that you can then build a bunch of coordination tooling that then would immediately be accessible to billions of people. Not that like would be accessible behind a click wall, login, sign up. That drop-off is terrible. Instead, make it just like a pull directly in the UI.
More atomic.
Yeah, exactly. I think like that could be super valuable, and it would enable millions of people to coordinate and take action together like that. And I think if we did that now, I think tons of problems could be solved much faster.
Awesome.
Thank you very much.
Juan, thank you so much for joining us, and looking forward to having more startups going to be built in this space.
Yeah, thank you so much for having me. This was great. And come talk to me or James or Ruben, who are back there, about starting companies in the space. We'd love to support and help. And a number of our team is going to be here throughout the hackathon, so go talk to them. All right, see you.
Thanks, everybody.